Hey folks, Matthew Lanigan here with BayWa. I just see quite a few people logging in, so we're just going to give it 2 or 3 minutes and then we'll start things up. Thanks so much. Hey folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here at BayWa. Just want to do a few housekeeping notes here before we get started, but thank you all for joining. We really appreciate you taking the time out of your busy schedules to be with us in Enphase and learn about the new IQ8. Enphase is a fantastic partner. We're really excited to be helping get this product to market. Continuing education is super important to BayWa internally and externally, so we're happy to be sharing some knowledge with you today. If you do have questions, you can put them down into the bottom right corner. We will take breaks throughout the talk so that there will be time for questions. So just put them down in the right corner and then we'll do it throughout the presentation. Without further ado, I'd like to introduce Tony Vernetti. He's the sales trainer with Enphase.
Thank you, Matthew. Appreciate the introduction. I'm going to go ahead and show my screen here now. And I'll turn my camera on just momentarily so you can see I'm a real human being here. Sometimes it's easy to forget that in this virtual world that we're doing here. All right, so today we're going to talk about the Enphase Energy System featuring the new IQ8 Microinverter. And this presentation is really geared toward distributors. So we're going to go into a little bit more detail about individual components that are required for the system that that you need to know about. So I'm just going to turn my camera off here again. So just confirm you can all see my screen that says components of the Enphase Energy System.
Yes, we can.
We're looking good. Okay, great. So I'm as Matthew said, I'm a sales trainer at Enphase Energy. I've been with the company for about 2 years, and I've been in the solar business for about 13 years. I got my first job in solar in 2008. I've mostly worked in sales positions for contractors over the years, but I have worked for a couple different manufacturers as well, and even did tech support for a short stint. So I've done a little bit of everything. And I live in Monterey County with my wife and 4-year-old daughter. As Matthew said, I encourage you to use the questions interface. It's great to see those questions come in and kind of have a log of those at the end. It helps you, put down the questions while you think of them, so you don't, not the end of the session trying to remember that question that you had a half an hour ago. So today's agenda is we're going to cover the advantages of the new IQ8 microinverter for solar, the available system configurations that are possible with the IQ8 and their use cases. And then we're going to really go into detail about the key components required for these different configurations. And we've got a few learning objectives here. After this session, you should be able to do all these items, describe the key features of the system, describe what's unique about the IQ8, understand and explain the differences between the available configurations, understand which components are needed for the different configurations, and lastly, understand how the new Enphase load controller is, how it works and how it can help improve the homeowner experience. So let's start with the IQ8. The IQ8 is our smartest and fastest microinverter yet. The key difference between the IQ8 and earlier generations is that it has an ability to provide backup power to a home during a grid outage, even without a battery. Now, how is this possible? The IQ8 has an advanced microchip called an ASIC. ASIC just means application-specific integrated circuit. It's a chip that's designed specifically for one application, in this case for a grid-agnostic or grid-forming microinverter. It's actually 1,000 times faster than the previous generation of microinverter, which means that it can change its current output extremely fast. Actually, it's sub-cycle, that's how fast it is. This allows it to adjust its current output to, based on changes in the power demand of the home. So, when something instantly turns on, like a air conditioner that has a startup surge, or a big appliance like an oven turns off, you immediately have a change in that power demand, and the microgrid can adjust to that extremely quick to maintain stability in the microgrid. If you've been in solar for a while, you'll know that other inverter companies have attempted this in the past, but their solutions could typically only offer a limited amount of power relative to the rating of the inverter, and normally just to a single receptacle too. So you would have people running extension cords across their whole house from their refrigerator to their inverter to try to keep their fridge going. Not exactly ideal. With the IQ8 and the Enphase Energy System, the homeowner will have automatic and instant backup power for their essential loads with the full available power of the solar array. The fast response time also means that a relatively large system, by that I mean solar system, can be connected to our smallest 3.3 kilowatt hour battery without a major impact on stability or performance of the microgrid. Naturally, you also have all the same benefits of distributed architecture, such as higher energy yield, minimized impact of shade, and no single point of failure. The IQ8 is available in 5 models covering a wide range of power. The IQ8 and 8 Plus have similar power ratings to their IQ7 counterparts, as you can see. This makes it easy for designers to change plans from the 7 to the 8 if desired. For example, the same number of IQ8s can be installed per branch circuit as an IQ7. Then we have the IQ8M, which is a new power class of 330 VA. The IQ8A, which is very similar to the IQ7A at 366 VA. And then the IQ8H, which is our highest power model at 384 VA. So this IQ8H can be paired with modules up to around 530 watts with little to no clipping losses. So with the sunlight backup, with the IQ8, we have a new system configuration, and we've created this simple table to kind of lay out the 4 available configurations with an IQ8. So the first is solar only. So this is a conventional grid-tied solar system designed to save homeowner money by running their home on clean energy, and it can be managed with the Enphase app. Now, when I talk about solar only, I'm not talking about backup power, right? A solar only system is a grid-tied system without backup capability. The next option is the truly innovative solution we have, which is called sunlight backup. This configuration can provide backup power to the home's essential loads if the sun is shining on the solar array. When offering this solution to homeowners, it's critically important to communicate not only the benefits, but also the limitations due to the natural variability of the power output with the sunshine. Next is the Home Essentials backup option, where we integrate a battery which offers emergency backup power to the home's essential loads 24 hours a day. Battery sizes start at just 3.3 kilowatt hours. And again, now there's a lot more flexibility in terms of sizing a large solar system with a small battery. Lastly, we have the full energy independence configuration designed to provide backup power to all the loads of the home. The solar array and battery size can be customized with the help of Enphase's free system planner to meet the specific energy and power needs of the home. We're going to cover how each of these works in a little bit more detail later in this session. So before I go on to the configurations, we need to review some new product names that we have. So over the past couple of years, especially since we've released our backup battery system to the market, we've received a lot of feedback that the names are getting a little strange, a little bit hard to remember. So our marketing team took all that feedback, and now we're rolling out a simplified approach to our names where the Enphase brand is really emphasized. So I'm going to be using the new product names in this session. So to avoid any confusion, I'm going to go over these names one at a time so you know what I'm talking about. So our battery system has been called both Ensemble and Enphase Storage. With the new advanced feature of sunlight backup with the IQ8, we've changed the name to the Enphase Energy System. This new name encompasses all possible configurations with or without batteries. The Encharge storage system, or Encharge battery, has been renamed the IQ battery. The N-Power, which is the MID or smart switch of the system, it's been renamed the IQ system controller. With the IQ8 and its grid forming capabilities, we have a new smart switch that works with the IQ8s, and it's called the IQ system controller 2. The Envoy or IQ Envoy, which is the key communication device of the system, it's been renamed the IQ Gateway. My Enlighten or Enlighten has been renamed the Enphase app. And Enlighten Manager, which is essentially the professional version of Enlighten, has been renamed the Enphase Installer Platform. So I'm just going to pause for a moment here before I go on to the configurations to see if we have any questions about the configurations that I went over high level earlier or these names that I just reviewed.
There are some different questions coming in. How does the IQ battery fit into the new 2021 CEC regarding Rule 64.8?
I'm not too up to date on actual code numbers, but I might be. If you can tell me what that refers to, I could probably answer your question. Is it a rapid shutdown requirement?
I'm not sure myself off the top of my head, but we can round back to that for you. We'll follow up.
Okay.
And then normally install IQ7, IQ8 Plus, and disconnect requirements are normally met with the breaker installed in the panel. I do not normally install a separate disconnect.
I wonder if they're talking about rapid shutdown. So with the IQ8 and any kind of backup power configuration, you have to use the IQ system controller 2 and also install a rapid shutdown switch that Enphase provides. And when that rapid shutdown switch is activated, it opens the relay for the PV and disconnects the PV, which has been approved as a rapid shutdown. I mean, it's an approved rapid shutdown method for our system. So maybe I think when I do have some content specifically about rapid shutdown. So hopefully once we get to that, that'll kind of help clarify a couple of things. All right, well, let's go ahead and keep on moving and go over some of the components here. So here we have the 5 major components to an Enphase Energy System. The IQ8 microinverters themselves for the solar array, IQ Combiner 4 or 4C, IQ System Controller 2, IQ battery, and IQ load controller. Now if you're familiar with the IQ battery system or InCharge battery system, you'll know that we have a kind of a new model that is a different form factor. It's not replacing the first generation. It's going to be available in addition. The reason it exists is because we get battery cell packs from 2 different suppliers to just address some of the supply chain challenges that everybody has had over the past couple of years, just ensure that we can produce enough batteries for the market. So just a few details about the IQ battery 3T and 10T, which is the newer model. These units are a little bit thinner, as you can see, than the original versions. They're going to stick off of the wall that they're connected to a little bit less, about 7 inches shallower, actually. They're also wider, however. So if you have limited space horizontally on a wall, you might want to go with the first version. Otherwise, they're very similar. They have the same exact energy capacity, same continuous power and peak power ratings. They also have integrated IQ8 microinverters, and the warranty and the price is all the same. And there are just very minor differences in installation. The IQ Combiner 4 and 4C houses the breakers for the solar system branch circuits. It also houses the IQ Gateway, formerly called the Envoy, the communications kit, and cell modem. So how is the IQ Combiner 4C different from the 3C? The difference is that it accommodates hold-down kits for all 4 breakers. Now, why is this needed? Since the IQ8 is a multi-mode inverter, which means it can grid form, it can potentially deliver power or energize the conductors even if it's disconnected from the grid. The NEC requires any reverse-powered circuit breakers to have a fastener. And this wasn't needed with IQ7 and earlier models or for other brands of regular kind of standard grid-tied inverters because there's an exception to the NEC rule for grid interactive inverters, since they're designed to instantly turn off if disconnected from the grid. So an inverter disconnect was sufficient. However, whenever the IQ8 is being used in a backup configuration and therefore grid forming, the PV breakers must be bolted down with hold-down kits. So for this reason, the Combiner 4 or 4C has to be used with IQ8 solar systems in backup power configurations. It can also be used for solar-only systems without backup capability. And those, if it's only a solar-only system without backup, then the hold-down kits wouldn't be required. It's backward compatible with IQ7 and earlier systems. I mentioned it has the gateway built into it, and the communications kit must be purchased separately installed. The communications kit is a wireless communications kit that allows for comms between the components in the backup system, namely the system controller 2 and the batteries. And then lastly, an Enphase cell modem must also be installed. It's essentially a backup internet connection in case the home's network loses power during an outage. The combiner models that have a C at the end, like the Combiner 4C, that just means it includes the cell modem in the package. So since a cell modem isn't always required, for example, if it's a solar-only configuration, a cell modem isn't a required component. That's why we offer the Combiner 4. Now, the cell modem that comes with the 4C is a Sprint T-Mobile modem. If you know or your customer knows that that service is not going to be very good, it's not going to be adequate at that location, then there is an option. They can install an AT&T modem. So if that was the case, they would just get the regular IQ Combiner 4 and then install the AT&T compatible modem. So here's an image of the hold-down kit for the IQ Combiner 4C, which can accommodate 2 breakers each. Got a little diagram here showing the rough, approximate location. So as you can see, you would have one hold-down kit on the left side for the left-hand 2 breakers, and then a second hold down kit on the right side if there are more than 2 breakers that need to be held down. Again, these must be installed and breakers bolted down whenever the combiner is being used in a backup configuration. Compatible breakers, which have the required hole for the bolt, are listed in the tech brief, which I'll make sure that you have a link to the tech brief at the end of this session. Now let's move on to the system controller 2. So this model specifically must be used with IQ8s in any backup power configuration. It has some additional hardware under the hood that's required. The original IQ system controller, or Npower, can't be used with the IQ8s on the solar array. The controller 2 has an additional relay for PV, which allows us to disconnect the PV from the AC load bus. It also has a spot to connect a rapid shutdown initiator. Now, why is this component needed? Rapid shutdown compliance has 2 requirements. First, the solar array voltage must be under 80 volts within 30 seconds, and the conductors must also be de-energized. With previous microinverters, the PV disconnect or breaker would do this because of built-in anti-islanding. But since the IQ8 is a multi-mode microinverter capable of forming a grid, if the PV disconnect is turned off, the conductors may still be energized. So the rapid shutdown initiator opens up the PV relay and initiates rapid shutdown of the IQ8s, and that allows us to fully comply with rapid shutdown requirements. It's also backward compatible with IQ7 or earlier generations. It can accommodate up to an 80 amp breaker for generators, whereas the first generation could accommodate just a 60 amp breaker. So you could connect potentially larger generators and get more power from those generators. And hold down kits are also required in the system controller 2 for the PV circuit, battery circuit, and if there's a generator integrated, it also must have a hold down kit because they're reverse fed breakers. The hold down kit for the IQ system controller is not the same as the kit for the IQ Combiner 4C. This is an important thing to note. With this hold down kit, it's a 1-for-1 kit as opposed to 2-for-1 like the combiner kit. So 1 kit is needed for each individual breaker. So before I move on to the next slide, I want to see if there are any questions because I know sometimes the hold down kit topic can be a little confusing because we have the 2 different components with different kits.
I'm unaware of any similar CEC requirements for breaker hold downs. Would be nice to get confirmation of this.
So I missed the first couple words, Matt. So they're asking for confirmation of the requirement for hold down kits?
Yes.
Okay.
The CEC.
Let me make a note of that, and I'll have to follow up at the end of the call, or I mean after this session with
Sure.
some documentation on that.
Another one, why do we need the modem?
Yeah, sorry, go ahead.
There's 4 or 5 here. Why do we need the modem? From John.
So we require the modem basically just to improve the chance that we're going to have a reliable internet connection to the home. Now we know that modems cell service is not super consistent across North America. There are areas where there is poor service or even no service. So I understand why people would like to avoid the cell modem in some cases, but it is a requirement in order to commission a system. The fact is, when people attempt to back up their home network equipment, oftentimes they forget a component. They might have a modem and a router, and their internet service provider might have a component near their panel that has power, must have power too. So we've just seen a lot of situations where people expected their internet service to be functioning, their normal network at home, and it would go down with the power outage, even if they attempted to back it up. Now, because the homeowner, really the only way for a homeowner to access their system is through the internet with the app or their computer. If they have no internet service, then they can't effectively change any settings or see how much power they have or energy they have left in their system. The system's still going to function properly. It'll still provide backup power and work properly, but they'll have no visibility over the system. And if there are any issues that need to be addressed or troubleshooting, Enphase wouldn't be able to help them out.
Okay. Is the IQ8 with the Enphase battery able to work totally with no parallel connection to the grid? I mean, with an ATS, for instance, that will transfer to the grid in case of outage.
I'm not sure I totally understand the question. It sounds like you're describing the sunlight backup configuration where essentially the IQ8 can form a microgrid and power the home even if there's no battery present. Now, for that system to work, there must be a system controller too there, which is essentially the ATS. It does a lot more than an ATS, but it functionally is what you're describing. It disconnects from the utility grid, and the IQ8 can power the home even without a battery. The assumption there being that the home's loads don't exceed the available power from that solar system, which can be really vary a lot depending on how much sunshine. And actually, I have a couple of slides that kind of go into how that sunlight backup or daytime only backup system kind of works.
To clarify, for solar only systems with IQ8, the system controller 2 is required, but the IQ combiner is optional.
It's kind of the other way around. So when Enphase uses that term solar only, we're talking about a grid-tied system that doesn't provide backup power. So a solar-only configuration, therefore, does not require the system controller 2, because of course, you don't need to disconnect from the grid. And the use of a combiner isn't necessarily required either. Most installers use the combiner because the Envoy is built into it. It simplifies the installation, but it's not necessarily required to use the combiner for a solar-only configuration. It would be required for a sunlight backup configuration where you where it is providing backup power because you need those hold-down kits.
Is the last one here, is the IQ controller 2 service entrance rated in Canada?
That's a good question. I'd have to review. That question was asked actually a few weeks ago. My understanding is that in Canada, an additional disconnect switch would be required upstream of the system controller 2. So I think technically in Canada it's not. I just don't know exactly why that's the case.
Great.
Any other questions, Matthew, or was that it so far?
That's good for now. Yeah.
Okay, let's keep moving on here. All right, so for all backup power configurations, the IQ gateway, formerly called the Envoy, the breaker for the IQ gateway must not be installed in the combiner. Now, the reason is that the IQ combiner can at times be disconnected from the system controller by the relay, and this would obviously cause the Envoy to lose power. And we want the Envoy, or the gateway that is, to constantly have power as much as possible because, again, it's the communication device, it's the monitoring device. It allows us to change settings and behavior of the system. So we want it to be on as much as possible. So therefore, for all backup power configurations, the gateway breaker has to be located in one of the following locations. Could be in the generator breaker inside the system controller 2, if this slot is not being used for a generator. Now there is a breaker, of course, that's inside the IQ combiner that's normally used for the gateway. However, to be installed in the system controller 2, it must be an Eaton breaker. And the breaker that's in the combiner may or may not be an Eaton breaker. My understanding is that sometimes it is and sometimes it isn't. So if that breaker isn't Eaton, it can be moved over to the generator slot, but if not, then you would have to sell them a breaker, an Eaton breaker, to be installed in the generator slot. Another option is to install an Eaton quad breaker in the upper right-hand location, which is the neutral forming transformer location. Therefore, you would be able to connect both the neutral forming transformer and the IQ gateway to this one quad breaker. And the third option would be the protected loads or backup load sub panel. It can also be installed in there if it just happens to be easier for the installer to put it there. It doesn't make any difference. Okay, here I've got a few pictures which depict the rapid shutdown initiator and how it's connected to the system controller. And I just realized that that has, I'm going to put the correct name here so you recognize it from our ADLP and spec sheets and stuff. It's called the Enphase System Shutdown Switch. There we go. Okay, so it's actually made by IMO for Enphase. The Enphase brand is on there if you get the Enphase supplied one, but the IMO model is exactly the same and can be used. It's wired into a terminal block that's located right here in the IQ System Controller 2. Now this terminal block that's pictured, this doesn't actually exist in the original IQ System Controller, and this is the reason why only the System Controller 2 can be used with IQ8s, because we need to have the system shutdown switch with IQ8s on the solar array. If the IQ System Controller 2 is being used with IQ7s or earlier, the rapid shutdown switch isn't required, but you would need to actually install a couple of little jumpers into this terminal block in order for it to function properly. That's depicted on the far right here. I guess one more kind of technical detail for you guys to note. For an IQ8 to actually go from grid interactive mode to grid forming mode, it has to be commissioned with a System Controller 2. It's actually the software process of commissioning that will enable grid forming functionality for the IQ8. So if they aren't installed with a System Controller 2, or for example, if the System Controller 2 fails, the IQ8s are going to default back to regular old grid interactive mode. Okay, here's a quick little reference table regarding compatibility. So again, with the IQ8s, we require the use of the IQ Combiner 4 or 4C or the IQ System Controller 2 because of hold-down kits and rapid shutdown requirements. But if it's an IQ 6 or 7 system, they can use any of the available models. Let's talk now about the IQ load controller. So this is a kitted solution for load control, which contains the contactors and power supply needed for that feature to work. It's designed to make the installation of load control a lot easier. If you've helped any installers get the individual components to build their own load controller with our directions, you probably understand that that was a little bit of a mess and not very easy. Sometimes hard to find the right parts. So anyways, we got a lot of feedback from our customers that it would be great to have a kitted solution that has everything that's needed, and that's what the IQ load controller is. So what does it do? With load control, a homeowner can make sure that specific large loads, which could potentially maybe overload the microgrid and shut it down, or potentially drain the batteries very quickly, those loads would get turned off immediately when the utility grid fails. And then the homeowner with the Enphase app can actually manually restore power to these devices if they want to. Now this feature is fairly configurable as well. So for example, the behavior can be customized for each individual load differently. For example, one load could be set to turn on or off depending on the battery's state of charge. This might be done to prevent large loads from totally draining the battery. Or loads can also be set to only have power if there's an integrated generator and it's operating in parallel with the solar. Therefore, you would have that extra power from the generator. Now for the sunlight backup configuration that I mentioned, which where you have backup power from the solar inverters without any battery, we require the installation of 2 IQ load controllers. Now please note they must be the Enphase branded and kitted IQ load controller, not one that's built from individual components. Let's see. There's also a new load control setting specifically for sunlight backup, which is designed to essentially power the loads on one at a time, starting at 9 o'clock in the morning, which is going to reduce the chance of a microgrid collapse. And there's also a gap between those loads turning on, so that if there is a load that continually overloads and shuts down the microgrid, then that load will be excluded from the startup sequence with the next try. Okay, a little bit more detail about what's possible with the load controllers. Each load controller can control power to 2 zones. A zone can be either a 240 volt circuit or 2 120 volt circuits. 2 IQ load controllers can be installed per system, so you would have a total of 4 zones potentially. For sunlight backup systems, 2 load controllers must be used, okay? Another interesting note about this device is that it can be also used for solar circuit shedding. So with earlier generations like the IQ7 or IQ6, there's a ratio that we have of a maximum of 1.5 to 1 solar AC power to battery AC power. And that's in order to allow the batteries to be large enough to absorb all the power from the PV system and avoid that microgrid getting overloaded. So in some situations where you've got, say you're retrofitting a system with a very large PV system and you're adding batteries, you might want to disconnect some of that PV based on the size of the battery so that you have a stable microgrid. So again, the IQ load controller can be used for shedding that portion of the PV or disconnecting that portion of the PV. In an Enphase Energy System microgrid, all microinverters on the solar array must be from the same family. And those families are highlighted here. In other words, microinverters from the IQ8 family can't be mixed with IQ7s or IQ6s in the same microgrid on the solar array. So sometimes we get asked by customers who already have an IQ7 system, why can't they just add a few IQ8s to their system and have a sunlight backup system? The reason it's just not going to be a stable microgrid because of the very different ways that the IQ7 and IQ8s behave and how quickly they react to changes to power demand and things like that. So it's important just to be very clear with customers when that question comes up. You can't add IQ8s to an IQ7 system for a backup power configuration. There are ways to have both of them on the same array for a solar only configuration, but they would have to have a separate envoy. There's no good reason to do that. So another question that you might get is, well, I've got a small IQ7 system. I want to increase the size of my system and have sunlight backup. If that's the case, then they would actually have to replace all their IQ7 microinverters with IQ8s for a sunlight backup configuration. My advice there is to recommend just keeping the IQ7s on the solar array, add some solar panels with more IQ7s, and then use that money you would have spent on replacing the IQ7s on a battery instead. That customer is going to have a much better backup power system. Okay, well, we talked a lot about the solar only and sunlight backup configurations, so I'm just going to kind of breeze through these here. Just some simple single line diagrams. These are also going to be in a tech brief that I'll make sure that all of you get. So as you can see here, a typical solar only configuration will have IQ8s with the solar array connected to an IQ combiner with the built-in gateway. The mobile connect, cell modem is pictured here. It's not always required, so that's an optional item there. And again, since this is solar only, there is no Npower or system controller to disconnect from the utility grid. With sunlight backup system, we have to add the system controller too. They also must have an essential loads panel. You can't effectively back up an entire home with solar panels only. So we recommend an essential loads panel with a maximum of 4 120-volt circuits. We don't recommend trying to back up 2 40-volt circuits with sunlight only, again, because of the variability. And typically 2 40-volt loads are very high power appliances, electric ovens, water heaters, things like that. They're very likely to overload a sunlight only kind of microgrid. And as I mentioned, we do require 2 of the IQ load controllers for the sunlight backup system so that we can control power to all 4 loads that are in that essential loads panel. So I've got a couple little animations here to kind of illustrate how a sunlight backup system works in the real world. So this example is with a 10 kilowatt DC system, and which is an 8 kilowatt AC rating based on the microinverter power output. The amount of available power depends on the irradiance or intensity of the sunshine. On a sunny day with clear skies, the available solar power, the available power at sunrise will be low. It'll gradually increase throughout the day until midday, and then it starts to gradually decline until the sun sets. When the sun rises, the microgrid will power up. The IQ system controller will disconnect from the grid. If the system can produce enough power for the electrical loads, the microgrid will stay up. But if the loads exceed the available power, then the system is going to shut down, and obviously the power will go out for that homeowner. On a partly cloudy day, the available solar power is going to fluctuate a lot as clouds periodically block the sun. If the home's power demand ever exceeds the power of the solar system, then of course the microgrid is going to shut down. After a few seconds have passed, the system is going to attempt to restart again. And if the available power can handle it, then it'll work. But if the power demand still exceeds the available solar power, it will not work. It won't be able to start up. It will attempt repeatedly, multiple times over increasing time intervals to allow the solar system power to hopefully increase along with the irradiance. And hopefully the homeowner will also realize the system is trying to start and will turn off as many loads as possible. So we're trying to be really clear, give a really clear message to solar professionals, salespeople specifically, that when discussing sunlight backup systems with homeowners, it's important to not just explain all the benefits of the system, but be very realistic with them about how the system might operate given what kind of loads they have connected to it, and also the climate where they live. A sunlight backup system is going to operate a lot more reliably in Southern California, which has a high percentage of clear sunny days, versus the Pacific Northwest, which has a lot more overcast and cloudy days. So here we've got a single-line diagram of the sunlight backup system. So you can see now, in addition to the solar and the combiner, we now have 2 IQ load controllers in the bottom left, and an IQ system controller here too, which is the disconnect switch or microgrid interconnect device, which will disconnect from the utility grid. Right, Matthew, I think now is probably a good time for me to take another pause here for any questions that might have come in.
Don't see any new questions, just a few coming in. Yeah.
All right. Well, let's move on, which is the next configuration option we have in the tech brief, which is the Home Essentials Backup Configuration. So now we're including batteries with the system. And as I mentioned earlier, we have a lot more flexibility in terms of sizing solar with batteries. A relatively large solar system can be paired with just a small 3.3 kilowatt hour battery. A typical system is going to have around 10 to 20 kilowatt hours for a good homeowner experience. Even though we now have a battery, we still highly recommend an essential loads panel. So the installer can designate which specific electrical loads are backed up by the battery and just select loads that the battery is capable of powering, as well as an IQ load controller to, again, be able to shed certain select loads which could potentially overload the battery or drain it very quickly. So a little bit more about the flexibility that designers have now with the IQ8s. And this is related to that 1.5 to 1 ratio that I mentioned earlier. So with the IQ8s, you can pair a relatively large solar system even with just a small IQ battery 3. So the limit is actually the same for all different models. Now up to 48 IQ8 micros can be installed, and that's any of the models that we have if a single IQ battery 3 kilowatt hours being installed. That's a much, much greater flexibility compared to that 1.5 to 1 ratio. Now, if more than one IQ battery 3 is being installed, which is nearly always going to be the case, then the limiting factor is actually in the IQ system controller. The PV breaker rating at a maximum is 80 amps, which means that 64 amps of continuous current can feed into the IQ system controller from that breaker. So that would translate to 64 IQ8s, up to 52 IQ8 pluses, 44 IQ8Ms or IQ8As, or up to 40 of the most powerful model we have, the IQ8H. And a simple single line here of the Home Essentials backup. So all the components that we had with a sunlight backup system, but now we've added an IQ battery right here. And our last configuration we call the full energy independence configuration. This is very similar to the Home Essentials backup. The only real difference is the size of the battery connected to the system. Obviously, kind of by the title, the name of the system implies that it's designed for whole home backup. And up to 4 IQ battery 10s can be installed with each system controller too, so that would be up to 40 kilowatt hours of capacity. For larger homes that have split buses, for example, like a 400 amp or 800 amp split bus, they can actually have 2 systems installed. So they would have 2 system controllers with batteries and solar connected to each one of them. They would essentially operate independently from each other. They don't share power or anything like that. But for homeowners that do require larger than 40 kilowatt hour systems and they have a split bus, they can have 2 separate systems. And then there's single line that I've kind of pulled out from the tech brief there. Now it's important to note that there's a certification course that's required for installation of IQ8s. I've got instructions on this slide. I'll make sure that you get this slide deck to refer to. Essentially, installers have to first have gone through our standard installer training for installing Enphase storage, and in addition, taken an IQ8 installation course. Once they've completed that course, it takes about a business day for that certification to kind of get registered within our system. Then they would be allowed to use the installer app to commission a system successfully. All right, so I'm going to actually pull up this tech brief that we have that goes into the system use cases here. So I'm going to make sure that Matthew has this to share with all of you. The title is System Use Cases for IQ8 Microinverters. And it goes into a little detail about the different configurations. It's got the single lines that I showed you. But most importantly, at the back here, it has a really useful table that has the component type on the far left. The next column is the product name and SKU number. And then we have the 4 different configurations. So if you're designing a system for somebody that's one of these configurations, it's going to be very convenient for you to refer to this table. For example, with solar only, you can see it tells you that you need microinverters, a combiner, but do not require the system controller, load controllers, and so on and so forth. Now, if we look at the sunlight backup column here, you can see with this configuration, you're going to need the combiner. You don't need the gateway because it's already included with the combiner. You would need the IQ system controller too. You would need 2 IQ load controllers, an Enphase system shutdown switch, the communications kit, and it also has additional details on the breakers that would be required for the system as well. And we also have another tech brief here, which will make sure that you get, which is a comparison of backup configurations which have IQ8s versus IQ7s. As I've mentioned a few times with the IQ8s and their grid forming capability, we have to have some additional components when you have the IQ8s that you wouldn't necessarily have to have with IQ7s in a backup configuration here. So again, this should be a very handy reference table for you. All right, Matthew, well, that kind of covers everything that I planned on reviewing today. So were any other questions typed in?
Yeah,
Or
we got 5
does
or
anyone
6 here.
feel like coming off of mute and asking questions? That's fine as well.
Okay, I don't think we have the capabilities during this specific webinar, but here's a few. Okay. If load controller 2 is compatible with IQ7 Plus and IQ8, what's the advantage of an IQ8 rather than using previous generation of product?
Well, the advantage really is the ability to have a sunlight only backup system without a battery. You can't do that with IQ7s. And the other advantage would be more flexibility in sizing PV with battery storage. So again, with the IQ7 series, there's a maximum ratio of 1.5 to 1 solar AC power to battery AC power. And with the IQ8, you can install a much larger PV system with a small battery. So that doesn't apply with every situation, but a good example would be a homeowner that has a relatively large PV system. Say they've got a 12 kilowatt DC system, 10 kilowatt AC system, but they only want a small battery to back up their refrigerator and a couple small items. With the IQ8, they can do that. They can get just that small battery for their essential loads. With an IQ7, they would have to get a larger battery in order to stay within that 1.5 to 1 ratio.
And on the solar only side, why is the combiner required? I thought the modem was only required for customers with sunlight backup and or battery backup.
Yeah, you are correct. I'm sorry if I misspoke or if that wasn't clear, but with a sunlight backup only configuration, the combiner isn't necessarily required. So you might have noticed that on the table here that I was showing here with the IQ use cases. So solar only here, it says 1 combiner. And if you look down below here for gateway, it says 1 gateway required, parentheses, if not using IQ combiner. So I agree that it's a little bit unclear in the tech brief, but just to be, try to clarify things for the sake of today's session, a combiner isn't a required component for a solar only system. It would only be a required component for a backup configuration, which would be one of the 3 on the right.
Great. How linear is the power disconnect curve without a battery, i.e. cloudy day and system disconnects under load? Is there any brownout prevention?
I'm sorry, Matt, could you just say that one more time?
Sure. How linear is the power disconnect curve without a battery, i.e. cloudy day and the system disconnects under load? Is there any brownout prevention?
That's a great question. Honestly, I'm not quite sure how to answer it. The IQ8 microinverters actually have sort of a brownout functionality to help sustain the microgrid when there are big fluctuations in power demand. I'm not sure if this is answering your question, but essentially it makes the system more resilient, because if those microinverters on the solar are pushed to their limits in terms of their power output due to a spike in demand in the microgrid, they respond by actually all together lowering the voltage slightly to reduce power consumption. And that can create a little bit of a brownout condition, little like for flickering of lights, but is really effective actually at keeping the microgrid up when you have those spikes in demand. So I apologize if that's not too clear. If you'd like to email or send that to me by email, Matthew, I might be able to get a better response from one of our field application engineers.
Sure. Does the Enphase storage system do feedback control to allow feedbacking the bus beyond 125%?
I believe that's a feature that we would call power control system, or PCS. We have a tech brief that goes into detail on that, Matthew, which I can send to you as well.
Sure.
But yeah, I think the answer to the question is yes, with power control system.
Is the Enphase certification required to install IQ8s as solar only, or is it required for backup configurations?
It is, I believe it's not required for solar only. I believe when it was first implemented within our software, it was required for IQ8 across the board. But my understanding is that the requirement for certification has been lifted if the IQ8 is being installed, again, with solar only without any backup components. I'm going to check on that though, and if I find out otherwise, Matthew, I'll get back to you.
Sounds good. And we have Greg asking, can you share the slide with the new versus old part names again?
Sure. Just 1 second, making notes here. Okay, so yeah, let's go back to that. One of those early slides with the part names. But actually, I apologize. Matthew, were they asking about the new component names like IQ battery and so forth, or the parts list?
So. And Greg, we'll follow up as well. We have this documentation that we can share with you also. Another one here, you said the IQ8 can handle up to 500 plus watt modules and no clipping, but if the output is 366 VA, is there clipping?
So, clipping occurs when, the power output exceeds what the microinverter can handle, right? Now, it's a common misconception that PV modules, solar panels, consistently produce their rated power. And the reality is the test conditions that they're tested in when they get that DC rating of 360 or whatever it might be, they're not real world conditions. They're artificially cool conditions in a laboratory with a very fixed amount of sunlight that essentially replicates a very bright sunny day. In the real world, temperature has a big impact on the output of a solar panel. And on a warm, sunny summer day when you have high irradiance and the potential to reach a high level of output, the temperature of the solar panel is also a lot hotter than test conditions. And if you look at the spec sheet of a solar panel, you see what's called a temperature coefficient. And all that means is that basically the hotter the panel gets, the power output is essentially reduced by a fraction of a percent with every degree Celsius of the temperature. Not sure if that came across very clear or not, but what I'm trying to get to is that in the real world, panels don't reach their full DC power rating. And there are also other losses in the system, like wiring losses, a little bit of expected soiling on solar modules and so forth. So typically a ratio of the DC power of the module to the peak power of the microinverter of around 1.3 to 1 is kind of optimal. You're going to have little to no clipping at 1.3 to 1. And in some climates and more northern latitudes where you're going to have less intense sunshine, you could even go well above 1.3 and still have little to no clipping. And we do have a tech brief actually that goes into great detail on that has simulated clipping losses for all kinds of different pairings of solar panels and microinverters to kind of give a little bit more realistic number, actually put a number to what a system might experience in the real world. And I'll share that with Matthew as well.
Great, and last question here, just to confirm, the sunlight backup does not require a cell modem.
So the sunlight backup system and any backup system does require a cell modem. So let me bring up that sheet here again. So again, here, the sunlight backup system is third from the right. So when I scroll down here to the mobile connect modem line right here, yeah, now I'm gonna have to kind of walk back what I said. So this table is, well, I said it's extremely useful. I acknowledge it can be a little bit confusing as well. Here it says that mobile connect number is 0, and that's because it's already included with the IQ Combiner 3C or 4C. So up here, we've got the IQ Combiner 4C listed, and we're saying that this is required for the sunlight backup system and the other backup systems here. So yeah, I acknowledge looking at it now that it's not that clear, but I can tell you for certain that the mobile connect modem must be installed in order to be able to commission a sunlight backup system or any system that does backup power.
Great, I think that's it for now. So thank you, Tony. Really appreciate you taking the time to train us on this. Just to let folks know, the IQ8s are arriving towards the end of March. We will be stocking these across Canada. I'd encourage you all, if you haven't signed up for our web shop yet, please do so. You can go in there, you can see price, availability, spec sheets, warranty docs, install manuals. This presentation will go out to you all as well, so you'll be able to reference it at any time. If you have additional questions, please reach out to your BayWa sales reps. They can definitely help. And yeah, just thanks again, everybody, and thank you, Tony. Enphase is a tremendous partner and fantastic customer service. So if anybody has any follow-up questions, I just encourage you to reach out to them.
Great, thanks, Matthew, and was happy to be here today.
Take care, everyone.